given that y is equal to the root of x, find dy dx using the first principle. So this is how we're going to solve our question. Now we know that dy dx is the same as f prime of x. So we'll say f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x over h. Okay, now we have that our f of x is equal to the root of x, which will therefore mean that to find f of x plus h, we'll substitute wherever there is x with x plus h, so to be square root of x plus h. Now we substitute this in our equation. So say f prime of x is equal to limit as h approaches 0 of the root of x plus h minus square root of x over h. Now to solve this, what we're going to do is we're going to multiply both the numerator and the denominator with the conjugate of the numerator. So it will limit as h approaches 0 of everything there. So we say square root of x plus h minus square root of x over h. Now multiply the numerator with its conjugate, which is square root of x plus h. Now the sign change to positive, then root of x over the same square root of x plus h plus a square root of x. Now we expand the numerator, so this gives us limit as h approaches 0 of square root of x plus h times square root of x, just give us x plus h minus, when we multiply that with the other remaining, I'm going to get square root of x, square root of x there, multiply by square root of x plus h. Then we now multiply this with the other one, so to give us, this one is negative, so we're going to have a minus, so that one is positive there, so we're going to have minus square root of x multiplied by square root of x plus h. Now negative and negative give us a negative, then square root of x times square root of x just give us x over everything that is down, h multiplied by the other part there, which is open bracket square root of x plus h plus the square root of x. Okay, now those two will cancel, leaving us with the limit as h approaches 0 of x plus h minus x over the denominator, which is h open square root of x plus h plus the square root of x. Now x and x down there on top, so we're going to have limit as h approaches 0, so it will cancel, so x and x cancelling, we're going to have h over h open square root of x plus h plus square root of x. Then we're going to have the limit, okay, h and h will cancel, so we're going to have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Now what we're going to do now is, wherever there's h, we're going to substitute this, so we're going to have, so now we're going to simply have 1 over square root of x plus 0, then say plus square root of x, like that. So this will give us 1 over the square root of x plus the square root of x. So this will further simplify to 1 over, so these are like terms, we're going to get 2 square root of x as our answer. So this is the answer to our problem. Please